Welcome to Mrs. Z's Chemistry. In this video, we will be talking about molecular or covalent compounds. When atoms share electrons rather than transfer them, these are called covalent compounds. The atoms are not losing or gaining electrons. We can interchange the words covalent and molecular, and they mean the same thing. These molecular compounds are formed with two nonmetals, whereas the ionic compounds that we've learned, they are formed with one metal and more than one nonmetal. So let's see if we can identify whether these following compounds are either ionic or covalent. Pause to see if you can work this out. Ki, or potassium iodide, is an ionic compound because potassium is a metal. Bleach, the hydrogen peroxide here, H2O2, is a molecular compound because it is made with two nonmetals. Chloroform, CHCl3, is a covalent compound because it is made with all three nonmetals. And lithium carbonate is an ionic compound because lithium is a metal. Now let's talk about what sharing electrons means. So this left-hand picture right here is a picture of a hydrogen atom with one positive proton at the center and then one electron in the electron cloud, which is just the region of space surrounding the positive nucleus at the center. When we have two hydrogen atoms, their electron clouds can overlap a little bit, and each of their electrons reside or sit inside that overlap, and that creates the covalent compound. Each electron or each atom gets to claim both of the electrons. Sometimes when we talk about sharing electrons, we get a little bit confused because when we were in preschool or kindergarten and we were taught how to share our toys, that meant we had to give up our toy and we didn't get to play with it anymore. But this is not the way atoms share electrons. Atoms share electrons in a way that they both get to play with both electrons simultaneously. Now let's look at this right-hand picture here with four hydrogens and a carbon making a compound. The carbon has four electrons to share, and it's sharing one electron with each of the four hydrogens. And each hydrogen has one electron to share back with carbon. Therefore, each hydrogen gets to claim two electrons, its own electron plus one of carbon's, and the carbon atom gets to claim 8 electrons, its own 4 electrons plus one each from each of the hydrogens. Let's go ahead and look at a picture of what it looks like to transfer electrons in ionic compounds. So here we have a sodium atom transferring an electron over to the fluorine atom. That gives sodium a positive charge and fluorine a negative charge, and they stick together because of their positive and negative attractions. That is what is meant by transferring electrons. In the covalent compounds here, the atoms are sharing electrons where the electrons sit in the overlap of the electron clouds. All right, let's learn how to name the molecular/covalent compounds. Because we are not dealing with charged atoms, the atoms are already neutral. Therefore, the compounds are going to be neutral, and there's not going to be a specific ratio between the two of them, between the two elements, for one set kind of compound. So between nitrogen and oxygen, there's actually lots of different compounds that have just nitrogen and oxygen. There's this, N2O4, N2O5 exists, N2O exists, NO2 exists, NO exists. There's lots of different compounds with just nitrogen and oxygen. And of course, we can't call them all nitrogen oxide. That would be very confusing. This is where we're going to use a Greek prefix on the first element to indicate how many we have. We have 2 nitrogens, therefore we will use the prefix di, which means 2. And then we use another Greek prefix on the second element and then change the ending to I, just like we did with the ionic compounds. The prefix for 4 is tetra. So we name this N2O4 as dinitrogen tetroxide. And this is all on the back of your periodic table. So let's go ahead and take a look at it. On the back, on the right-hand bottom corner here, we have our naming covalent compounds. And it gives you the rules, Greek prefix on the first element, plus Greek prefix on the second element, and the word "ide," or the ending "ide," and then there's the example. The Greek prefixes are in the upper middle kind of center of the back of the periodic table. We have tetra is for 4, and then di is for 2, plus all the rest of them for any of the numbers that we need. There is only one exception to this molecular or covalent compound naming rules here. The exception is that when you have only one of the first element, you do not include the prefix mono. So this is why we call it carbon dioxide for CO2 and not monocarbon dioxide. However, when you have only one of the second element, you do use the mono prefix. So NO is named nitrogen monoxide. And that's it. So molecular compounds are named fairly simply. Just so you know, we also have the ionic compound naming rules on the back of the periodic table as well, kind of in the middle of the periodic table. We have the naming ionic compounds here where it says to name the cation, then the anion with "ide." We never use prefixes. If you have a variable charge cation, then you use the Roman numeral, which here's some of the variable charge cations. Copper 1 means the copper has a 1 plus charge. Copper 2 means copper has a 2 plus charge, and so forth. This is not an exhaustive list, by the way. All right, let's name the following covalent compounds. Pause to see if you can work this out. Here are all of the answers. Sulfur hexafluoride, dinitrogen trioxide, dichlorine heptoxide, tetraphosphorus hexoxide. Notice that when the element oxygen is in the name, which almost all of these have oxygen, whenever the prefix ends in an A, then we drop the A and just blend it together. So instead of saying heptaoxide, we say heptoxide. Or instead of hexaoxide, we say hexoxide. All right, let's do the next practice problems. Write the formulas for the following compounds. Here are the answers. Phosphorus pentachloride is PCl5. Dinitrogen monoxide is N2O. Iodine heptafluoride is IF7. And carbon tetrachloride is CCl4. Now let's talk about polyatomic ions. Polyatomic ions are a group of covalently bonded atoms who have altogether gained an electron or more than one electron to have a negative charge. They're often called oxyanions because they most often include oxygen and are negatively charged. The common polyatomic ions are listed on the back of your periodic table, and you're going to use these polyatomic ions for the rest of the school year. So let's look at this a little closer again. The bonds are covalent, but altogether the molecule has gained or lost an extra electron, or more than one electron, so that the entire unit or little molecule is going to act as an ion and make an ionic compound. So let's look at this. We have phosphorus with 4 oxygen atoms, where you can see their electron clouds are overlapping a little bit, so they are covalently bonded together. But altogether, these 5 atoms have gained a total of 3 electrons, giving it a 3- charge. This is called phosphate. If you look at this one here, we have carbon with 3 oxygen atoms covalently bonded together, but then altogether, it has gained 2 electrons. Therefore, it has a -2 charge, and this is called carbonate. If you look on the back of your periodic table, you'll find this common polyatomic ion list, and it has all of the ions with their subscripts, charges, and their names. So here's the carbonate with the CO3 2- and its name. All right, so I would never ask you to memorize all of these. And even in AP chemistry, there's only a small handful of them that you're going to need to memorize if you don't already have them memorized because of how often we use them. However, your life will be much easier if you are very familiar with these. Because if you come across one of these polyatomic ions on a quiz or a test, but you're not aware of the fact that it's a polyatomic ion, and say you see NO3, but you think it's nitrogen trioxide or something silly like that, you're going to get the problem wrong. You need to recognize that NO3 is nitrate. Therefore, I recommend that you read this list of polyatomic ions every night before you go to bed. And then every morning as soon as you wake up, you're going to see this periodic table sitting on the back of your end table, and you're going to read it again. I know that sounds silly, but if you do it, your life will be much easier for the rest of this year. And here's the funny for today.